This video goes through how to solve the quadratic equation by factoring. So what we're going to use is the zero product property, is that if a times b is equal to 0, a has to equal 0, b has to equal 0, or they both do. So let's warm up just by factoring, and then we'll see how that comes into play when we have an equation. So here we would common factor out an x. We'd be left with x times 2x plus 1. Our next one is a simple trinomial. We're looking for two numbers that multiply to minus 12 and add to minus 4. So those two numbers are going to be minus 6 and plus 2. Our next one here is a tricky trinomial. You can use any method that you like. 1 and 6, 2 and 3. We're looking for numbers that are going to multiply to this minus 6, or multiply really to minus 18, and then add to minus 7. So 18 and 1, 9 and 2. Those ones are going to work as long as the 9 is negative, and then the 2 is positive. So then I can factor as 3x plus 2 and x minus 3. And then my last one here, I've got two terms. This one is a difference of squares. So x plus 3, x minus 3. Okay, now we're going to extend that to solving some quadratic equations. So what I'm going to do with this first one is I'm going to factor the left side. So x plus 5 and x minus 5. Now on the left, I've got two factors multiplied together to equal 0. So that means that my first factor could be 0, or my second factor could be 0. That means that the solutions to the quadratic equation are x equals minus 5 or x equals positive 5. Those are the two numbers that if you put them back in where the x is in the equation, they are going to give you the left side equal to 0, which is equal to the right side. So let's try another example here. Now we're factoring a simple trinomial, multiplying to minus 3, adding to minus 2. So we are here, we'd have x minus 3, x plus 1 equals 0. So that means my first bracket could equal 0, or my second bracket could equal 0. In this case, the two numbers that I would put in are 3 and negative 1. So let's write those down below. So we've got x equals 3, or x equals minus 1. Example C here, we have another simple trinomial. So I'm going to factor this as x minus 3 and x minus 2 equals 0. Solving each of those brackets would give me x equals 3 or x equals 2. Example D, here I've got a tricky trinomial. So I'm going to use my lollipop method. 1, 2, that's it. Oh, I guess I should write it maybe like this would be better here. So we've got 3 and 2, 1 and 6. Let's see, we would have 4 and 2, 3 and 4. Those ones are going to work as long as my 4 is positive and my 3 is negative. So I can factor this as 3x plus 2 and 2x minus 1. This one's a little bit trickier. For 3x plus 2 to equal 0, my x would have to equal minus 2 over 3. Similarly, in the second bracket here, 2x minus 1 to equal 0, that's a linear equation that I have to solve. It's going to give me a fraction for my x value. Okay. Another example here, we've got another tricky trinomial. So we've got 1 and 12, 3 and 4, 6 and 2. On the right hand side, I just have 1. And I'm going to start with this middle term here because I know the middle term has to add up to 1. So that means that my numbers are going to have to differ by 1. So I've got 3 and 4 here. As long as the 3 is positive, 4 is negative. So then I can factor this as 3x minus 1, 4x plus 1 equals 0. And again, I'm going to get fractions for my answer. So x equals 1/3. And then x equals minus 1/4. So again, setting the bracket equal to 0 and solving the corresponding linear equation. Here, this is the first time we've seen this with a number on the right-hand side. Not a big deal. We just have to rearrange it to multiply, or sorry, we need to rearrange it so that our right-hand side is equal to 0. And we can do that just by moving over the 77 onto that left-hand side. So we've got x squared minus 4x, and we'd have minus 77 equals 0. Now we're looking for two numbers that multiply to 77 and add to minus 4. Those two numbers would be minus 11 and positive 7. And then we're going to set each of those brackets equal to 0 and solve that corresponding linear equation to give us our solutions. So x equals minus 7. Okay, a couple more examples here with some different types of factoring. Here we've got a perfect square trinomial, x plus 5, x minus, or perfect square, difference of squares, excuse me. These are going to give us our two solutions as x equals minus 5 or x equals plus 5. Example H, we've got common factoring, so we can factor out an x from both terms. This time, x can equal 0 or 3x minus 5 can equal 0. Solving for x here, we will get x equals 5/3. So another example here, I not equal to 0 on the right-hand side, even though it is in factored form. So what we have to do here is expand and move the 32 over to the left-hand side to get it equal to 0. Now what I would do here before I factor is divide everything by 2 to make my numbers a little bit smaller, because then I can look for two numbers that multiply to 16 and add to minus 8, which actually factors as a perfect square trinomial as x minus 4 all squared, which means that I only have one solution here, which is positive 4. Okay, here we've got another example where it's not equal to 0. And we only have a y squared term, so I'll actually show you a different way to factor. There are two ways. Instead of moving the 30 over to the left-hand side, I'm going to move the 10 over to be on the same side as the 30. What that's going to do is give you a quadratic equation that doesn't have a y in it, so you can solve it a little bit faster using sort of a shortcut or a trick. So 5y squared is going to be equal to 20. So that's just taking the 10 over to be on the same side as the 30. Now what I can do here is divide both sides by 5. And then I'm going to take the square root of both sides. The only thing to be careful of when you're taking the square root, that you do get two answers, so positive and negative. The last one looks extra complicated, but it's not that scary. You just need to expand and move everything over onto the left-hand side. So when we expand, we're going to get 3x plus 6 plus 12 minus 4x equals 24 plus 4x minus 4x squared, 4. Then I'm going to move everything over to the left-hand side. So I've got minus 4x squared minus 4x plus 3x minus 4x plus 6 plus 12 minus 24 equals 0. So now I've got minus 4x squared, got minus 4 plus 3 minus 1 minus 4 minus 5x, plus 4x squared here, whoops. Then I've got 6 plus 12 is 18, minus 24 would be minus 6 equals 0. Now I've got a tricky trinomial that I'm going to try and factor. 4, 1, 2, 2, 1 and 6, 2 and 3. Let's switch them on this side. So I've got 24 and 1, 12 and 2, 8 and 2, 6 and 4, 6 and 4, 3 and 8, last but not least. So minus 8 plus 3, so this is going to factor as x minus 2, and then 4x plus 3 equals 0. And now I'm able to set my first bracket equal to 0, solve for x, and then I can set my second bracket equal to 0, and then solve for x by moving the 3 over and then dividing by 4.